Hello everyone, welcome to my channel. Today I'm doing something totally different. I'm going to start designing a very quick and dirty macro pad. My goal is to get it done within roughly one day. I should get the switches coming in tomorrow and hope to get the case designed today. So let's get to it. So for those of you who don't know what's a macro pad, it's basically a small keyboard, shall we say. I've seen with 4 keys, 6 keys, 8 keys, 9 keys and more, some with some knobs. So I really wanted something simple. And basically these macro pads are used to set these keys to be shortcuts for some stuff. So people use them for CAD, for example, to be a shortcut to a certain function, or gamers use it for certain button combos. Discord people sometimes use it for certain emojis. I actually want to use it for my recording, so I wish to have quick access to buttons to mute and unmute certain things. Switch between scenes. So right now you're seeing me with the full frame, and when I go to the corner I'm having to use the mouse and so on, and I want to just set up a keypad for this. And you may look into what I'm planning. So these are macro pads. There are a number of cases on Thingiverse, and yeah, I've ordered these switches. I have no idea what's the manufacturer. I have no idea if they're clicky, if they're noisy. I hope they are, because I like noisy, clicky stuff like here. Yeah, by the way, this is my daily keyboard. I got PlayStation, arrow keys. I got an initial D key here, a Gundam. I ordered this, a pack of 10 keys. I hope these are keys and I'm not ordering something else. And there's a microcontroller to interface to the PC and behave as a human interface device. I'm going to be using this just because I happen to have it. It's I think it's a Raspberry Pi Pico. Is it Pico? I think it's what officially the Raspberry Foundation call it. And this is using that IC, the Micron or system on a chip. You know, I think we're getting close to blurring those lines. Officially, it's a microcontroller. So this is the RP2040 Pi Pico 0, made by Waveshare, I believe is their name. It's pretty small, pretty cool. I mean, I can show it to you later because I have it already. And on this we have 20 GPIOs that are accessible on the edge. There are a few more on the bottom, if I can find a screenshot of that. But yeah, I'm planning, well, I only ordered 10 keys, so 10 keys would be the max I'm ever gonna wire up. So it should be good. So because I have enough GPIOs, I'm not gonna do a traditional keyboard where you'd have a matrix of detecting columns and rows, and based on which column and row is switched, you know which key has been pressed. I mean, that's the method that most keyboards use, you know, to not have a GPIO per key. But with 10, why not? Saves me having to install diodes, and I might do it in the future. So then coming to the pad, right? So the housing, that's what I'm going to design today. I've seen a number of designs and I could just download and print it, but I feel like I ought to design my own. I'm a mechanical engineer by profession, kind of, and first degree. Even though I don't get to do real design work anymore at work, this is a good way for me to keep practice. And I came across this design. I thought this design is really cool. It's like a fat Game Boy cartridge, right? I don't know. I think that's pretty interesting, pretty sick. see, did anyone else make it? Yeah. And I think it's very well designed in the way the top plate mounts on top of by these 4 screws, and the shape is pretty cute. And of course, I'm not going to redesign something that already exists, because that is too much literally reinventing the wheel. But yeah, originally I was planning to make it either tilted from the desk or making it, let me see, something like this that I can stick to the desk, or something like this. This is what I meant by tilted, not parallel to the desk plane. But or this I like this design. Is very minimalistic. You got just long screws spacing the top plate from the bottom. I like minimalistic stuff as well, but you know, this looked too cool. Why not try to replicate the PlayStation jewel case? So this is the PAL. I'm not sure if these cases were used in all regions. So whenever I've been shopping for used games in Japan, I've seen they use the thin jewel case as well, and it seems to have original branding. In fact, let me grab some. So actually both, right? So this is what we know as Resident Evil 2 or Biohazard 2. It's in the fat jewel case. And yeah, this is Tekken 3. And yeah, maybe I think basically both styles were provided, because it came with this. So this is clearly the insert for a kind of fatter version of the disc, at least. So anyway, so and also for reference, I don't know if this is a genuine case, because again, I bought this used. So this NTSC J Biohazard doesn't have any PlayStation markings over there. Hope the camera can pick it up. But in fact, let me switch to full screen for that. So the PAL versions of these jewel cases clearly have the PlayStation logo embossed or engraved in the cast. So I don't know if this is a genuine case. It doesn't have anything. It's like ribbed. Maybe you can hear that. And this looks like a really standard CD disc, but I suspect it's genuine, because look, it has the artwork on the inside. It has the label fitting. Everything looks how to say, genuine looking, and it's from Japan. So while I lived there, so I didn't buy this online on eBay or something. So my idea is to replicate the PAL case. Of course, it's not going to look too obvious to the casual user, and I'm going to print it all black, because I don't have PLA that's clear. But at least for the nerds out there, hope it might be obvious. So the CAD tool I use is a Solid Edge. Solid Edge for me is very similar to NX, which is one of the commonly used CAD packages for automotive. And yeah, I'm still wondering if we should do it 1:1 scale or scale it down. So I think 1:1 is a bit bulky. So got out my verniers, gonna check what's the external dimensions of a PlayStation jewel case. So what did I say? 130 by 143. No. Okay. 17.4. It's oh, I want to extrude the opposite way. Sorry. It's gonna look good enough. Good. Scratch. So 12 millimeters to the right. We want to be on that line, and then we want to come horizontally down and also be on that line. So here, I don't know. So we're going to 3D print this. So it has to be something the 3D printer can actually print. So I don't know. I have a 0.4 nozzle. So hopefully 0.4 is enough. Then let's extrude that. Let's delete that line we had earlier. And then let's extrude there. So now we want to, and we cheated. We didn't make this. So the jewel case obviously is continuous here. So we got to trim. Bye bye. And let's do the same at the bottom. Trim, 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 trim. Bye bye. Bye bye. Good. So yeah, now let's extrude that. Sorry. So we want to eat away, cut. Don't know, for this illusion, probably 0.6. Let's see what does that look like. I reckon that's already starting to look like a jewel case, right? Now let's try to write PlayStation. Go figure. Writing it again makes it look right. We got to try. And let's hope this font is not glitchy for extrusion, which it is. The S is gonna kill us. The S is gonna get into our ass. Oh man. What a pain. Do I have to go full course for getting this right? Seven, full course, come on. So, back to where we were. Subtract. Let's try 0.6. That looks about right. Hopefully it will show up in the print. We won't apply any softening to the edge. Or, I don't know. Can we try 0.3? It's all about what will 3D print with a PLA extrusion printer. Let's try PLA. 0.3. Good. Then what do we reckon is this radius? So that is a radius of around 3. So we want this edge 3. Is that going to interfere with our logo? What's your problem? Yeah, so the real thing, the radius does start pretty close to the logo. So that straight line will not actually show up. The real thing, right? But I feel it's a teensy too close to the edge, so that's a lot of work for the non-important stuff so far. And we still have to think how we're gonna print this, cause yeah, we're gonna need to print this bottom up to get that nice logo. Because if we were to print it upside down so that the PlayStation is on the bed of the printer, yeah, we won't be able to print the surface name so easily. So the you know, where we're seeing the groove, so if we printed this jewel case upside down, the letters will want to fall down to the bed while we're printing. So maybe we'll split this Yeah, that could be a solution. Maybe we make this, and this could be how we solve the issue of making it feel like a jewel case with these edges. If we print the case excluding this part and later insert this. I think that's what I'm going to do. So let's go back to the original mission. So now we need to put 9 keys. So what is the recommendation for the key sizes? Okay. So it's definitely not going to take a lot of space. What do you guys reckon? Scale it. So I've redrawn everything. So this is 75% scale. This was full scale. I don't know. I just feel this is way too much space. Maybe I was making, I don't know, 5 by 5 switches would make sense. But yeah, even at 75%, I think it's too big. But I'm not going to redo it the nth time again. Good. No. Okay, chain. Good. I reckon having, I don't know. Let's make that 5 millimeters. Ought to be good enough. Five millimeters would be the wall thickness of this case. Yeah, that should do it. What else? So it's interesting. So the jewel case also has a radius here. And also has a slight bevel. Question is, do we want to spend the time to make that light bevel? And will we be able to catch it? So first let's start with this chamfer radius. Good. And then, yeah, let's try to make that small bevel. And definitely this is tricky. So So of course, this where did we measure 3? And there we go. We have that piece, which is just 1.2 millimeters. And then what we'll do here is, this groove is the pain of my life at the moment. Cool. And then that is our PlayStation logo. Let's not forget to extrude that. So can't remember what we went for. 0.4. There we go. Now, time to print that. Oh crap. Okay. That way we'll lose this. Yeah. In order to not have that fine fine edge, because I'm sure it would just flop. Or print width, that small step, it just was messy. So yeah, remade that model. It's a shame, especially since I want to stick some label over here, some sticker with, I don't know, the like PlayStation text at the bottom, like you'd have on a Platinum game, or I'm not sure if a normal game had it, but at least the Platinum games have this border. I wanted to have that. Yeah, can't always have what you want. Hello everyone. So after several attempts, I got it done. So some things I had to modify in the design. I had to increase the spacing between the letters, because my 3D printer nozzle is 0.4 millimeters, and this couldn't fill the space between some of the letters. So I've ordered a 0.2 millimeter nozzle, so I might reprint this part in the future. I think for now that looks fine. The webcam and the lighting I have for filming is not doing it justice. Of course, it's not perfect, but I think it's pretty good. So you can see that. I mean, even while the cam is out of focus, you can read that. I printed this sticker at one of these kiosks where you can print photos of an SD card. Unfortunately, I don't know why the machine pre-cuts the stickers, and it cut off the top of the sticker in the appropriate place. It's snipped off part of this label, so I carefully cut it with a craft knife and stuck it on. Again, at a distance, and considering it's going to have keys on, it's not going to be visible. I've also printed the back. So the back is where I went for fast and dirty. So there are the holes for the screws to screw it in. There are these rings where I'll put the mounts, the rubber mounts or rubber pads. And conveniently, there's a small slot where the USB is. So you'll have to put in some sort of tool to lift it out. There you go. So next I have to cut the stickers around here, put in the switches, and wire it up. So I finally finished it. Here is my macro pad. I will be using this to control my streaming or recording software for these videos. With this, I'll be able to mute, unmute, switch between scenes, pause recording, continue recording at the click of a button, literally. One thing you might notice in close-up while tilting it, I've scratched the sticker, which I guess was to be expected. I didn't pay attention while assembling the inside, and it is actually photo paper, so yeah, it's not meant to withstand the abuse. So that's the first thing I would do differently. I would custom order a sticker for it instead. But overall, pretty happy. I love the way this, making the effort of printing this logo separately turned out. It makes it look more authentic to the style I'm going for. I think I might go for some translucent buttons. I think I'd put a blue one here, perhaps a blue one here, red one here, to kind of let you see the logo that's behind and match the color scheme. But I think for now these keys will do. These are the keycaps I had in have the base with the feet fitted. Actually, these feet are slightly bigger than the mounting plates I made for. I do have the other smaller rubber feet, but I was too lazy to go and get them. Let me explain what I did. So this is the inside. As I mentioned, each switch is totally hardwired. unshielded wire is the ground wire. So they're all connected to the same ground. They're growing through a 1 kilo ohm resistor. Probably not necessary and might cause some floating values. I'm not certain of that, but I just thought since all the switches connect to the same ground, there might be significant or some unknown level of current flowing through that ground, and I don't know how robust is the ground design of the RP2040 in this implementation. And as you can see, each switch is wired to one of the GPIOs. Look first at the code. So here's the code. So I basically almost copied and pasted some of the examples from the library from Adafruit. The code is very dirty. I definitely wouldn't recommend using this code because there's a lot of copy and paste. There probably is a cleaner way, but I just really wanted to get this project done, even if it's quick and dirty. So yeah, basically I set each GPIO as an in-out, set it as an input, and set the pull-up resistor on that GPIO. And I do that from pin 0 or GP0 all the way to GP8 because I have 9 keys. Then I have a sleep 1 second, so just in case while you're connecting it, you're pressing a key, it will not do anything. And then forever it does this loop. And the keys are mapped to function F13 to F21. So the Mac actually uses apparently some of these F keys. Windows does not, because most keyboards stop at F12. Cool softwares like OBS, which I use for recording, lets me set up hotkeys to that. And so this is simply the main loop, which is just checking what button is pressed. If button 0, okay, so because we're using it with a pull-up, it's inverted, so it's true when it's not pressed and false when it's pressed. So if not false, which means true, we will send key code F13 and we will wait 200 milliseconds just so it's not hammering too much. Another cool thing I did here is boot. So boot.py is apparently useful. It helps you configure features of the Pi at boot up. I probably don't need to do this each time, but why not? It enables the keyboard mode. I don't actually use consumer control, but I might add this later. It's to have like mute and multimedia control from this macro keyboard. The next thing, I don't know if I've coded it well, but I've set the GP0 to have a special function at boot up. So basically, if the GP0 input is, so the first key is not pressed, during boot up, it will not activate or mount or make visible the flash memory. Here we go, this is my computer. So first I'm going to keep it pressed and connect it. You get the discovery, and you see it detected circuit Pi. I can let go of the button, by the way. And it automatically opened on my other desktop the contents of this drive. So this is annoying, since most of the time I would not need to mess with these Python files. So if I now reconnect it without pressing any button, it will beep because it detected a new keyboard, but nothing happens here. So that's awesome. And yeah, pretty satisfied with that. So hope this is interesting for you, anyone else wishing to replicate this. Maybe you want to use proper code, which does, you know, the arrow and row scanning method for key presses. As I said, I didn't care. Maybe in a future version, I would put a switch up here to change the mode to like make these 9 switches have different functions based on where the switch is at. Because again, there are enough GPIOs to do something like that. It motivates you to make something similar. Maybe you want to make exactly like this. I know I'm going to use this, and in fact, I'm going to connect it now. and use it to end this recording. See you next time.